have basically, if I recall, the graphs left to go here, yes? Okay, and if you'll notice on both 7 and 8, they talk about solving graphically. When you see something that's solving graphically, first of all, we're not doing any algebra here, okay? Solving graphically, we are going straight to the graph, okay? So we have to be able to use the graphing calculator here. On this first example, first of all, what has to be true to be able to graph it on the calculator? What form do we have to look for? Y equals, yes. In order to type something into your graph, it has to be y equals. And I don't have that right here, do I? Okay, so with that in mind, we need to make it y equals. Now, in a situation here where there's just one variable, making it y equals is basically going to be, let's make this equation equal to 0. When you read the directions in the homework section, it says something, I don't remember the wording exactly, but make your equation equal to 0 by moving everything to the left or by putting 0 on the right. Basically, that's what they want us to do, though. So they want everything on the left side of the equation. They want the 0 on the right. We've already got this absolute value on the left. We're going to keep it over there. We have this 3 times square root of x plus 6. That is 1 square root multiplied by 3. So we're going to think of this as one term. How are we going to move the 3 square root of x plus 6 over? If it's a positive 3 square root of x plus 6, we're going to subtract it. If I subtract the term 3 square root of x plus 6 on the right, we're going to subtract 3 square root of x plus 6 on the left. So then I'm going to have the absolute value of 2x minus 1 minus 3 square root of x plus 6, and it's now going to equal 0. Now, by getting that equation equal to 0, we are good to put this into the calculator. So basically, the 0 is replaced with a y, and we are going to graph y equals the absolute value of 2x minus 1 minus 3 times the square root of x plus 6. Okay, so get the calculators going, and I've got something new to show you, don't I? Okay, are we there? I'm there. I say something new to show you because what's the first thing you have to be able to type in? Absolute value bars. Yes, you need to put the absolute value. If you just typed right over that without putting absolute value bars, your graph isn't going to show up right. Okay, so there's 2 ways I can come up with to get absolute value bars. The easiest way that I like to do this is to use my alpha shortcut. So if I use my alpha button, and then I go to F2, which is my window button, it brings up this menu here. And the top thing there is ABS, absolute value. And so I can get right there and type it in. Okay? So again, that was, I'm in my y equals menu. I go to alpha, or the alpha, and then I do F2, the window menu. And it pops up, that right there, number 1 is absolute value. Okay? So type in what you need to. So I have 2x minus 1. You get arrow past absolute value. Minus 3. And then I'm going to do a square root, which is down on top of the x squared button. And then type x plus 6 under the square root. Typed in, it should look something like that. And then we graphed a lot of crazy stuff last week, didn't we? So who knows what your settings are. Now, one thing I will mention. Up there at the top, does yours look like mine does now where one of those plots are highlighted? Okay, those are ways to turn on and off the stat plots. Okay, sometimes stat plots don't interfere with graphing. Sometimes they force the graphing not to work. So this is an easy place where you can turn on and off your stat plots. So I can just arrow up here, plot 1, and turn it off. I just hit enter on it to get it to turn off. And so now I don't have to worry about any of those points showing up. I'm going to do a zoom 6, which is my standard screen because I don't know when I last graphed. And if done correctly, your graph should look like mine. If it doesn't, go back and check your y equals screen. You probably typed something in wrong. Okay, that's going to be the first thing I'm always going to tell you. If you're looking at your graph and you're like, that's not what my graph looks like, unless I made the mistake, go back and make sure that it looks like mine. Okay, so that means next step I'm going to do is, okay, did I type this in wrong? You know. So work to get your graph to look like mine.
How do you get the absolute value?
So absolute value, the easiest place is to do alpha and the F2. It is also under math. So if you have that math button there, the math menu has pretty much everything you could ever want. Okay, are we working to get these graphs looking right?
Okay.
Does it look good now? Okay. You would think it's easy to just type it in, but man, oh man, the mistakes that happen. And I'm guilty too, because I made mistakes this morning. So, okay. With this in mind, guys, we were told to solve. Where are my solutions? Where are my solutions on this graph? Where my graph crosses the x-axis. You're looking for your zeros. Do we have a way to officially find those zeros? Yeah, don't just trace. Go into second calc. So second function of the trace button takes me to the calc menu. Remember the menu that looks like this? Go to number 2, which is 0. And then follow the prompts. So it's asking me left bound. So I'm going to arrow to the left. I'm going to be to the left of that where it crosses the x-axis. Enter. Right bound. Now I'm going to arrow to the right of it. Enter. Then I'm going to go back where it says yes, and I'm going to hit enter again. This is a 0 because A, it uses the word 0 and tells me it's a 0. Then also because the y value is 0. So one of my solutions, I have them rounded to 2 decimal places on my paper. Negative 2.36. And then repeat your process to find the other one, correct? So I'll start over again. Second to the calc menu. Number 2 to 0. Left bound. Well, now I'm going to arrow over closer to the other intercept. There, now I'm on the left of the side of the point that crosses the x-axis. Enter. Right bound. I'm going to go through the x-axis. Now I'm on the right of it. My guess is back in that ballpark. Again, it says 0, and my y value is 0. So my other answer is approximately 5.61. Are you getting the calculators to cooperate? That's half the battle, isn't it? Okay, so a few reminders here. The first thing we did is we made sure we got that equation equal to 0. After we got that equation equal to 0, we then graphed it as y equals whatever it is. And then from that point, you look for your x-intercepts. Fancy word for x-intercepts that are your calculator is going to be able to find is you're going to look for your zeros. Okay, so that's kind of some steps. If you need some steps of how the heck did we just do that, that's what we just did. Okay. I do have a few typos on this page. For instance, you don't have a B and I do. That's because I realized that mistake on like Thursday or Friday and I added it in. Okay. So we are going to do example B here. So if you would, take a moment to write on your paper if you haven't already. x plus 2 to the power of negative 1 equals x to the negative 1 plus 2x. Again, we're being asked to solve graphically. So I need it in a y equals form. How can I get this equation equal to 0? And again, we're not doing any fancy math. We're just moving stuff around. If I want to move everything to the left, how do I move an x to the negative 1 term to the left? If it's positive, I'm going to subtract it. How do I move a plus 2x to the left? If it's positive, I'm going to subtract it. So I'm going to subtract both of those things over on this other side. So I'm going to have x plus 2 to the negative 1 minus x to the negative 1 minus 2x equals 0. And then again, you're going to graph it. So you're going to be graphing y equals x plus 2 in parentheses raised to the negative 1 minus x to the negative 1 minus 2x. We're going to do parentheses x plus 2 in parentheses raised to the power of negative 1. We'll move out of the power minus x raised to the power of negative 1 minus 2x. Then I'm going to graph it. This is what it should look like. Are we saying what because it does look crazy or what because it doesn't look like mine? Okay. And this is why this is one of these equations that we use the calculator on. Because algebraically, this is not going to be an easy task to do. Okay. How many solutions are we looking for?
1.
Just looks like 1 here, doesn't it? Looks like it crosses the x-axis in one place. Same process as before, right? I'm going to go second, calc, or second in the trace button to my calc menu. I'm going to go to number 2, the 0 option. Now, left bound. When I start moving my cursor left, notice it's on that upper piece, isn't it? It's on that upper piece, but the farther you move left, it will move. So like right now, it kind of disappears into oblivion, and then it will appear from below. So it'll reappear as you keep moving left. Now, my left bound is going to be somewhere to the left of it, which happens to be above. Enter. Right bound is going to be somewhere below it. Well, to the right of it, which is below it. Enter. And then my guess, in all honesty, you could just hit enter again. But officially, my guess is going back to the area of the x-axis and enter. You should get an answer that matches mine. Negative 2.205569. Or I'm going to write down negative 2.21. Again, it used the vocabulary word 0 and my y value is 0. That's how I know it's a solution and it's a 0. Okay. Questions there? And a lot of this is just figuring out how to use the calculators. It really is. What are the tricks? Okay, we're ready for the next section? Now, I will tell you there's another typo, although this typo I didn't find until this morning during class, so it's not officially retyped. But this section down here is seeing grapher, failure, and hidden behavior. So the idea is being able to figure out what's going on in some of these wonky looking graphs, because that's really what they are. So let's start by looking at this one. Nice thing is it's already solved for y, isn't it? So we're going to graph that. We're going to graph y equals 3 minus 1 over the square root of x squared minus 1. And we're going to see what comes up on the calculator. Three minus the fraction. Remember, to do a fraction, I use alpha F1 as my shortcut. Don't forget the 3 minus part, or that will give you a graph that does not help you very well. As I found out this morning, I was all confused in my teachings. Does yours look like mine? Always a good thing when it comes up looking like the teachers, right? Or your neighbors, or I'm not sure Aiden's convinced. Okay, guys. What are you thinking? Could there be some answers here? And this is where it just comes down to some investigation work, okay? You can zoom in and see what's happening. However, on this one, you can actually use the zeros to figure out what's happening as well. So you guys ready to try that with me? If I go to my calc menu, second calc, and go to 0. Okay, so notice right now, they tend to plop my cursor on the y-axis to begin with. So right now, my cursor is on the y-axis, but there's no cursor seen because y doesn't exist there, right? So right now, you'll notice my cursor is invisible, and it says y equals nothing. That just means the graph doesn't exist at that point. So if I start arrowing left, arrow, arrow, eventually you hit a point where your y value exists, doesn't it? And your y value starts existing. Okay, so I'm trying to do left bound. My left bound is somewhere over here where my y values exist. I'm going to hit enter. Now for right bound, what I'm going to do is, right here my y value exists. I'm going to go one spot past to where my y value doesn't exist. So I can't see my cursor, but right there I'm going to hit enter. And then for my guess, I'm going to backtrack so my cursor does appear, and I'm going to hit enter. Did it give me an answer? It gave me an answer, didn't it? And here's the deal. It gave me an answer and it didn't shoot back an error. So that's a good sign. That means we do have a 0 at this negative 1.054093. Now, I do want to bring your attention to one thing, and I'll point this out more in the future, but what is my y value supposed to be right here? It's supposed to be 0. Well, what is 1.2 e to the negative 12? Okay, this is like scientific notation here. This is 1.2 times 10 to the negative 12. What's a negative 12 exponent do in scientific notation? It moves your decimal 12 places left, yes? So if I move my decimal 12 places left in 1.2, that means this is going to be 0.0000000000012. What do you know about that number I just read off? Very, very small, very close to 0. And that's part of just, these calculators aren't perfect, okay? While this should officially say 0, it's not coming up as 0, but it is a 0 here, okay? When they give you a number that is so tiny like that, assume that they mean 0, okay? So that means one of my solutions is negative 1.054. Have you found your other solution yet? You could probably guess if you wanted to. So I'm going to do second calc again. Get to my 0 menu. Left bound. Now for left bound, this time I'm going to move over to being on the right side of my graph. Now, my cursor has appeared, yes? I'm going to back it up a little bit to where my cursor doesn't exist. That's what I'm going to use as my left bound. Right bound, if I'm on the graph to the right of it, the cursor exists, enter. And then my guess is just putting the cursor down in that area. And this time you have positive 1.054. So we actually end up with solutions of plus or minus 1.054. Okay. Okay. Are you practicing with the calculators? Because that's half the battle right here, I promise. Okay, you ready to try B? They give us this equation. They have it equal to 0, so we're going to graph the y equals version, yes? Y equals x to the third minus 1.1 x squared minus 65.4x plus 229.5. Okay. Now, I will warn you, type this one in very carefully. There's so many places to make mistakes. X to the third minus 1.1 x squared minus 65.4 x plus 229.5. And graph it when you're ready. Same question. Is your graph looking like my graph? Now, I know there are some comments this morning. What is this graph doing? If you watch it as it graphs, and that is sometimes key. If you watch it as it graphs, you can see that piece on the left shoot up real quick. And then over on the parabola, it kind of goes up and down real quick. So that's telling me this graph is probably doing something like that. Okay? How many solutions you thinking? I see 2 being held up. Agree? Disagree?
Yeah.
Now, I have an issue with that, though, based on what I know. My highest power is what?
3.
My highest power is 3. What do you think that indicates? That indicates there's supposed to be 3 solutions or 3 roots. Now, what I will say, okay, we'll see what this turns out to be, whether it's 2 or 3. What I will say is that total number of solutions or roots does include imaginary solutions. Okay? So that is always an option that there's like something imaginary hanging out there. However, there's also the option that there's 3 real solutions here. Okay. Let's start with the obvious. There's obviously a solution over here, yes? So, you know what to do, right? Now, I will say, this one's tricky, isn't it? Have you started working on it?
Yeah.
Tricky because your cursor is like nowhere to be found, isn't it? You have to watch your x and y values. So I'm going to do second trace. I go to number 2, the 0 menu. Okay, left bound. Notice, where did it start me? It started me on the y-axis, didn't it? Up at 229.5. Okay, well, I'm trying to get over here, so I'm going to arrow left. And as I arrow left, not the best color for this. As I arrow left, I'm going to get, what is that, over around -9 maybe? Watch your x values. My x value is right there, almost -5. -7, -8. Now, as we approach this, Watch your y values here. Notice my y value is positive, yes? My y value is still positive, yes? Y value is still positive. Notice what happens now. Now my y value is negative. What happened when for my y value to turn from a positive to a negative? My graph had to have crossed the x-axis, right? So what we're saying, we never saw it pass through on this calculator. And it's just the way the calculator is sometimes when there's such big numbers, you can't see it very well. So right here, since this is at negative 18, I'm down here somewhere. I pass through this, and I'm down here. But I go back here, I'm positive. So for my left bound, I need to be after I've crossed through the x-axis over here, and I'm left of that value. So I need to be in the negatives. So where your y value is a negative, hit enter for your left bound. And if you look very closely right there, you can see where my arrow got put on, right? Now, right bound. So now arrow to the right. If you arrow to the right, 11.86, now I'm in the positive, yes? You can hit right, you can hit enter right there, or you can go another one if you want, it doesn't matter. And now that's my right bound. Does it look like maybe we're in the right spot? Maybe, yeah. For a guess, you can just stay where you're at or go back one, hit enter, and we have a 0 at negative 9. Did you get your calculator to cooperate? We have minimum one more answer, right? Maybe two. Depends how much you want to believe me. Okay, now, as we look over here, what's the obvious up here? That there's probably one more answer here, yes? However, my brain tells me there's 3 because the highest power was a 3. And if I give you another hint, imaginary roots only occur in pairs. So there'd have to be no more real roots if that's the case, but I can definitely see 1. Because it is so hard to see that, guys, I'm going to suggest that we zoom in over there. Now, I'm going to teach you a new zoom technique. So go in your zoom menu. And for a situation like this where I know exactly the area I want to zoom in on, I like ZBox. Because with ZBox, you box what you want to zoom in on and hit enter. So if I go into number 1, ZBox, take your cursor. Oh gosh, my cursor is way over there. Work to get it over by the bottom of that curve, bottom of that parabola point, yes? All I really want to see is the bottom of that curve, yes? So I've got a cursor. You don't have to be as close as I am, but I'm trying to get it in pretty close so I can see what's going on. If that's a corner where I want the box, I'm going to hit enter. So that kind of puts a point there. And now I'm going to move over and down. So I'm on like a diagonal, I'm going to the diagonal corner of the box. And I'm going to hit enter here once I have that box placed the way I want it. And now my graph is going to regraph. And it's just going to zoom in on that little boxed area. So now how many more answers do you think there are?
2.
Now you can tell there's 2, right? Now we're not arguing about it. Now it's a fact. And can you use your 0 function to find this now? Yeah. So you can do a second calc. We can go into number 2, 0. Left bound, enter. Right bound means I want to be between the 2, enter. And there's one of them at exactly 5. And then repeat the process to find the other one. So second calc, 0. Left bound. Now my left bound is between them. Enter. Right bound is past it. Yes. We're going back here and hitting enter. And my other one is 5.1. So we have zeros or solutions at -9, 5, and 5.1.
Please excuse the interruption. This is Mr. Miller, elementary principal. I want to provide an update to our lockout situation. Teachers and students, we're going to remain on the lockout for the remainder of the day. You can move in and out from classroom to classroom, go to the restroom, etc., continue teaching as you normally would. No one is to exit or come into the building without Officer Sayers or a Tiffin County deputy present to help them with that. Again, we are going to continue with our lockout. You can continue doing business as usual inside the building, but no one in or out of the building at this time. Thank you.
Okay. On that note, guys, when you go into work and homework now, okay, the ones at the beginning of the notes, we're not doing this, right? You have to go back to Thursday now to figure out what we're doing. You're going to have somewhere we were doing the modeling. You're going to have somewhere to solve them algebraically. Like at the top of this page, we were solving algebraically, yes? And then you're going to have somewhere it says solve graphically. If it says solve graphically, the only work you do is to maybe move stuff to the one side of the equation, but then use your calculator to make life easy, okay? So you guys have some work time. Use it.